going to solve some GATE previous year questions from the chapter sheet metal operation. Now this is a GATE 2014 set 2 question. Now reading the question, it says that a rectangular hole of size 100 mm by 50 mm is to be made on a 5 mm thick sheet. The thickness of the sheet is 5 mm of steel, and they have mentioned the ultimate tensile strength and the shear strength as 500 megapascal and 300 megapascal. So they have mentioned sigma ut as 500 megapascal and shear strength tau as 300 megapascal. Now what they're saying, that a hole is made by punching. So this is a punching process. Okay, neglecting the effect, they have mentioned we have to neglect the effect of clearance. What they have asked, the punching force in kilonewtons. So they have provided us with two data. They have also given us the ultimate tensile strength and the shear strength also. They have given this data to confuse us. It is the shear strength which will cause the punch and not the tensile strength. So what is the punching force required? It is punching force will be tau into the area. What is area here? Area is the surface area through which the punch will pass. Now tau is 300 megapascal. Now we'll calculate the area. So if we see the rectangular block, something it would be like this. So the area, this is the 100 mm length and this is 50 mm, and they have given the thickness as 5 mm. Now the area through which the shear will take place will be these areas. Similarly this side also, if we draw it like this, this like this, so this area also and this area also. So the area will be 2 times of 5 into 50 plus 5 into 100. Now solving, we will get 300 into is 5 into 50 is 250, 500 750, 750 into 2 is 1500. So we will get it as 45,300, 45 of 450,000 Newton, sorry 450,000, which is equals to 450 kilonewton. So the right answer is B. Option B is the right answer. Now going to the next question. So this is a question from GATE 2016 set 3. Now reading the question, in a sheet metal of 2 mm thickness, so thickness of sheet metal is 2 mm, a hole of 10 mm diameter. So the dia is, I am noting it by 5, you can, or equals to d, you can also write it in terms of d equals to 10 mm, needs to be punched. They have again mentioned the yield strength in tension of the sheet material is 100 megapascal and its shear strength. So it's a similar kind of question like we solved previous. So sigma yield is 100 megapascal and tau is 80 megapascal. So they have asked the force. So again force is equals to tau into area. In this case area is pi into d into h. So 80 into pi into dia is 10 mm into height. Height is basically depth or thickness. So h is equals to ts, which is 2 mm. So it is 1600 pi, which is 5026.548 Newton, which you can write in, because they have asked it kilonewton, so it is 5.0265 kilonewton. That's the answer. Now going to the next question. So in this question they have mentioned a 10 mm deep cylindrical cup with a diameter of 15 mm is drawn from a circular blank. Neglecting the variation in the sheet thickness, the diameter of the blank is. So if I we know the formula, but I am trying to solve it without using that formula and how we got to that formula. So let us see this is a, let's say, a cup, and the cup is like this. So what they have mentioned, this is cup is 10 mm deep and its diameter is 15 mm. So they want the dia of blank equals what? Since it's a sheet metal operation and no material is being removed, so volume is constant. Now we can write pi by 4 d blank square into thickness. Let the thickness of the blank and the cup is same, because they have mentioned the variation in sheet thickness to be neglected. So there is no variation in sheet thickness. It will be equals to pi by 4 into d cup square into thickness plus pi by 4 into d outer minus d outer square minus d inner square into height. Now p by 4 d square blank into thickness equals to pi by 4 into d cup square into t plus pi by 4, we can write it as d outer minus d inner into d outer minus plus d inner into h. So we can say that, let's see, from the figure we know that this is r inner and this is r outer. So r outer minus r inner is basically thickness. So d outer minus d inner will be 2 times of thickness, and they have mentioned that we have to neglect the sheet thickness. So they are saying that d outer is in the order of d inner only, which we can write it as d cup. So pi by 4 d square blank into thickness is equals to pi by 4 d cup square into t plus pi by 4 d outer minus d inner can be written as 2 times of thickness, and d outer is equivalent to d inner is equals to d cup, which can be written as 2 times of d cup into h. Now cancelling both sides, pi by 4 gets cancelled, thickness gets cancelled, so it becomes d blank square is equals to d cup square plus 4 times of d cup into h, which we can write as dv equals to under root of d cup square plus 4 d cup into h. Now substituting all the values, we get dv as d cup square is as 15 square plus 4 into 15 into 10. Solving it, we get 28.7228 mm, and they have asked it in mm only, so this is the right answer. Now going to the next question. So this is a question from GATE 2018. Now what they have asked, they have given a figure, and what they have asked a percentage scrap in the sheet metal blanking operation. They mentioned blanking operation for continuous strip of sheet metal as shown in the figure. So now in blanking operation, the piece which we get after making a hole, so we know in blanking operation the piece which we get after making a hole is of use. So this is a piece of use and this piece is scrap. Now we will calculate in one punch how much is the scrap portion and how much is the used portion. So from center to center distance we are taking it as center to center distance. So length, what is the length? Length is d by 2 plus d by 2 plus d by 5. So it will come as 6 d by 5. Now width, this is width. So width is d by 5 plus d by 5 plus d, which is 7 d by 5. From figure we are getting these values. So what is the volume of metal in one punch, or one punch, or I can say it as one blanking operation. So the volume of the metal is L into W into thickness. Thickness is not given, so I am taking it as P. So it is 6d by 5 into 7d by 5 into thickness, which is 42d square T by 25. This is the volume of metal. Now volume of blank is pi by 4 into d square into T, pi by 4 d square T. So what is scrap? Basically scrap is V metal minus of V blank, and what they have asked percentage scrap. So I have to calculate percentage scrap. So percentage scrap is V metal minus VB by V metal, which is equals to 42 d square T 25 by 25 minus pi d square T by 4 divided by 42 d square T by 25. d square T, d square T, d square T gets eliminated, which we can write it as 1 minus of pi by 4 into 42 into 25, which we get. For percentage we have to multiply it by 100. Sorry, I not written that. So for percentage we have to multiply it by 100. So it becomes, on solving we will get 53.25 percentage answer.